Hello.
Good morning.
Morning. How are you?
Doing pretty well. How are you?
All right. So I think Brian said he's going to be late, and we have probably a couple other people showing up today. So while we're waiting, would you like to give an update or talk about some things that are going on? Or
Sure. I have been continuing to listen to the computational psychiatry conference, which has been very interesting. A variety of things. They talk a lot about different ways to use Bayes in modeling, and I know that's like pretty, like, there are all kinds of fields that use that tool, so that's been interesting. The one I just started, the talk by Thomas Parr, who co-authored the active inference book. I haven't really gotten into that one yet, but that one should be good. And then there was one other talk that I thought was particularly interesting about fatigue, and the hypothesis about fatigue was that it was, I don't remember the exact phrase, but something to do with your like metacognition about control, the control that you have. So that was interesting because when I first heard it, I was like, that seems really convoluted and like over intellectualized for something like fatigue. But then learning more about like what fatigue is like clinically, I thought that hypothesis was very interesting. So that's been a cool thing to listen to so far. What else? The reading group I'm in with some of my classmates from my philosophy program, former classmates, we read more about dance and affordances last week, so that was cool. Well, the first time I mentioned it, it was mostly about proprioception, and it was like philosophy of art and stuff like that. But this one was more explicitly about affordances. And one of the papers was about using the concept of affordances to help teach improvisational dance. Like if it was like written by a dance instructor, talking about how if your students are hitting this plateau and like failing to develop their skills, here's a tool. And I talked about affordances and how to teach dance using that framework. So that was neat. I feel like there was one other cool thing I found that's worth sharing. Let me consult my own update in the chat. Oh yeah, Cognition Futures was great. I really enjoyed your bit on synergentics. That was really helpful context. Yeah, that was neat.
yeah, well, that's good. Yeah, I just put that together and probably go over that today a little bit. So, but yes, I think the reading group's going pretty well, and it sounds like that's some interesting work on proprioception and dance and affordances and all that.
Yeah, it's really neat.
Yeah.
Yeah, I think I want to, maybe I'll bring it up the next Cognition Futures reading group. There's one of the papers where the author is like responding to an objection, and she talks about representations. Like that's a main way that she responds to the objection. And I don't think she has to talk about representations at all. So I think I shared the papers already, but maybe I'll share more thoughts about that. Just, I think that the stuff we've been talking about in the reading group in Cognition Futures could maybe help, like, I don't know, it could it gives us tools to respond to that objection in a way that doesn't require talking about representations and is relevant to like a bigger picture, not just like this author's little thing about dance. It's about how if you can like represent your own, what Fuchs would call like the subject body, can that be the object of a representation, or the intentional object, like the subjective body itself?
That would be actually quite useful for our reading group, I think. There's a lot of stuff there with like proprioception and bodily representation, and actually that's stuff that, of course, is relevant to virtual reality, but it's also relevant to a lot of other sorts of action and perception type stuff. So, there's a lot of, for example, if you're doing things like dance, or you're doing things like, walking around a room even, there are a lot of things that you're using your bodily representation for. And, building it and storing it, I guess, is, pretty key to cognition, because if you're doing a lot of things with your body, then that's one thing you need to have. So, we've talked about a lot of these, we've talked about the rubber hammer illusion, but there are other studies where people like will get limbs amputated, and then they'll have like these phantom limb pains, but also they have to remap their space around their body, and they have to learn how to walk differently. And they've even done, experiments with insects where they've taken legs off of insects, and they watched how they've adapted to moving, because insects have, they have a way of walking, and it's very automatic. You have these central pattern generators that generate motion, but if you take one of the legs off, they can learn to move. They just have to like readjust their posture and things like that. And, there are a lot of ways that you can look at this too, not just they're taking insect legs off, but other types of. Yeah. Well, yeah, thanks for the update.
Yeah.
Morgan, how are you? I don't know if he's ready yet. So I'm doing all right. I've been working. Oh, okay, he's eating breakfast. Well, I've been doing all right. I've been doing the Cognition Futures group, and we have our class that we're sponsoring this term out of Albany. It's the 499 class. Looks like they're making progress on their project. We have other types of chats going on the side, so there are always things that are kind of bubbling up. But that's mainly what we've been doing this week, is the Cognition Future stuff, and then I'm involved in some, go through these periods where there's some conferences, and we're doing conference submissions, and then putting together lectures for that. And then we're also doing, there are phases where we're writing things and preparing for the next round of submissions and other types of things. So right now we're kind of in a phase where we finished up some conferences, and we're kind of moving into, kind of prepping for a new round of things. So, but we also have things that we need to follow up on. So we have, there are all sorts of different papers that we've written and put out in various forms. And then there's more work to do. So thinking specifically of the Gibsonian information work. So we have the Gibsonian information. We had a preprint that was chopped down for a conference paper. And once that conference paper was out, which was very sparse, then we have, more opportunity to sort of develop that further and refine that work. So that's something that, and we talked about this when Jesse and Avery and myself met in Chicago in person, and we talked a lot about Gibsonian information and how to formulate it. And that's actually one of the things we've kind of talked about with Gibsonian information, is this notion of this embodiment, or these like simple internal representations of space and of the body, and then having information from your environment come in and spatially relevant or temporally relevant, and then integrating all of that. So that's ongoing, and we're kind of working on a new version of that preprint. We're also wanting to do maybe more work with that. So Gibsonian information was presented at Neuromatch, was presented at another, I think it was at Bika AI. But these are things like where you always want to keep advertising this work, but you also want to keep moving it forward. So that's something that we're, maybe we can come back to a little bit later. We also have this stuff that I think I showed several months back on continual learning, where we have this model of continual learning with agents, sort of modeling the lifespan of an agent and moving, modeling cognition maybe as a thing that's not just trial by trial, but it maybe not even like, epic by epic. Like if I engage in some longer term behavior, like, I go on a coffee break, or I dance, I spend like 2 hours practicing dancing or martial arts or something. That's a lengthy period of time. That calls for the sort of dynamical cognition treatment, but even farther out. So you have like memories consolidated. You have, you're living a life, as it were, over days, months, years, and then of course there's reproduction, and so fitting all that into a common framework. But that's something that we have that one paper we're working on the more of the continual aspect, the theoretical aspect, and then this other work we had talked about doing something with cultural and genetic inheritance of agents, but that never really got off the ground. So that's sort of in limbo. So there's a lot of planning there that we need to work on. That'll probably take up the rest of the year. Then there's the open house, which we keep talking about. So again, open house will be sort of a overview of what we've been doing, probably an overview of what we did for this year, because it'll probably be at the end of the year. And then maybe if people want to prepare some short presentation, they could do so. We'll have our Google Summer Code involvement. We'll have our mentorship involvement. We'll have like some of our other conference papers. We had a couple of big papers this year, or actually at least one. And that'll all just kind of be in a quick session, maybe a couple hours. I mean, quick relative to the achievements, but I like to celebrate our achievements when we make them. So, and even if we don't have like a big paper or anything, it's still nice to have like that recap of everything, because it helps you move forward and think about what's next. Okay. So I'm going to maybe talk about a few things. Actually, I don't know if Jesse's going to come today, but I can go over the stuff I talked about in our Cognition Futures reading group I guess it would be a larger audience, but let's see. Let me share my screen. So what I did for this reading group is we started talking about synergies, and we were talking about it very broadly, so we didn't take any one perspective, and this idea of embodied cognition. And then we wanted to know more about sort of the roots, because we started talking about Haken, who's Herman Haken, who's a physicist who's influenced a lot of dynamical cognition. And so there was a little bit of, I think we were getting to the point where we were kind of name checking things, and we didn't have a good grounding in what that meant. And I like to kind of dig into some of the history of that and see where it goes, because you learn a lot more about what something, if you're reading something and they make these references, they're kind of implicit and you don't know why they're saying it, and it's important sometimes to know why they're saying something. So this is something I came up with for last week. So this is a mind map, of course. So we start with this. So we have like these people who were deep in the past, sort of. They give us this basis, and then we're going to talk about two people here, J.A.S. Kelso and Michael Turvey. And they did some interesting work together. They're out of the university. I think this whole thing sort of was formulated at the University of Connecticut. So there's a group at Connecticut, or the University of Connecticut has a strong sort of dynamical cognition tradition. You know, interested on a lot of these type of topics. But so the first person here is Nikolai Bernstein, and Nikolai Bernstein is from the Soviet Union. He wrote a lot of his work in Russian, and he was interested in motor physiology. So he was interested in things like, dynamical sort of motor behavior, walking, dancing, running, those sorts of things. And then, just any sort of movement. And so there's a whole field called human movement science that, he's kind of inspired. There's also like motor control and things like that in neuroscience. He's also inspired. There's a Bernstein conference, if you're familiar with that, where they talk about, I guess it's largely motor control and motor physiology, but there's a lot more. But anyways, that's who that is when you hear the name Bernstein. And, so he wrote a lot of things in Russia, and it got translated into English. And he really was like kind of not just a motor physiologist, but a cyberneticist, or at least he thought that there was like room for this systems perspective where you had cybernetics as a basis, because this is at the time when, cybernetics was big, right? So that was a part of this motor physiology. And if you think about the way motor physiology has been treated, it's been treated as this closed loop system. So we have some we could call them a subject or an individual, and they're getting feedback from their environment. So if they're moving their arm or they're walking, they're generating something in their internal physiology. They're generating a signal. That signal's checking the environment somehow, and there's a feedback. So postural adjustments would happen when you generate some signal from your nervous system, some neurophysiological signal, for feeding it forward to the limbs, and then the limbs would adjust themselves based on if they're in the environment, and then you get this adjustment to your movement. So if you've ever been like swimming, you know that like you make certain movements, and those movements are, if you don't necessarily learn how to swim in the water, but you also learn how to move your limbs in the air. So you have to make some adjustments to your limb movements when you're in the water, because the physics of the environment are different. I mean, it's just one example. And so there's this closed loop feedback that is involved in this. Now, the problem that Bernstein saw, though, later in his work was that there's this maybe rift that will develop. And I think, this is maybe why cybernetics never really took off in neuroscience. One reason is because motor control and cybernetics aren't, there's a rift there. Cybernetics doesn't fully explain motor control. And so we know from like some of the readings that we've done with respect to some of the stuff with subject and object and all this, that maybe cybernetics doesn't fully explain that. And that's what, that's kind of one of the problems with it. We've had, like if you read some of the later work on motor physiology, some of the more recent work, you see this problem where it's not just this closed loop feedback. There's a lot more going on. There's a lot of auxiliary cognition, for example, that plays a role. So this is all in this tradition. Now that influenced Turvey, and we'll get back to that in a minute, but J.J. Gibson and his wife also influenced Turvey. J.J. Gibson, of course, did ecological psychology. He did, looked at things like optical flow and these other aspects of the environment, where the environment is basically coming in to the senses. So if you have some visual motion, that is going into the person's sensory system. So Gibson used to have some examples. Like he had an example where you would stand on the back of a train in the caboose and look out at the rail line, as it goes by. So the railroad tracks are moving away from you. That's the visual illusion. And so you would see like this, these railroad tracks that are kind of like this, you're just moving along the railroad tracks, you're moving forward, and your body's moving forward. And then your perspective is that this is moving away from you and that everything is moving out to a point. But there's all this visual flow information. And so this goes into your retina, it goes into your brain, and you perceive that motion. We call it apparent motion. And then there's also real motion where you're moving. So there's a lot of stuff with having to do with movement, having to do with other things. And that was part of that. And his wife was interested in development, which is interesting. And we cite that in the Gibsonian information paper. But anyways, so Turvey's perspective was basically heavily influenced by Bernstein and Gibson. And Turvey's done a lot of work on motor control and things like that. But, again, motor control has this other aspect of some of the other parts like cognition being involved. And, there's also this issue of dynamical systems, which is that to say that cognition is not like trial by trial, as we know. It's something that you do in the world, in everyday life, and you can do it at different time scales. So, you might interact with the world in 30-second increments, or you might sit on the back of a train and watch the tracks move away from you, those sorts of things. Those are all not things you can easily capture in maybe a 10-second trial. And then, keep replicating it. So that's that. And then, Turvey had a lot of collaborators. He had a student, J.S. Kelso, who then they collaborated together, and together they came up with this idea of formulating sort of maybe a theory and a model of dynamical systems for rhythmic behavior. So they were interested in rhythmic behavior, like tapping your finger on a table, or, walking, which is a stride, where you get like a certain number of steps per minute. That's a rhythmic behavior. And so, understanding the dynamical system behind that is what basically they wanted to do. Now, Kelso actually had some influences as well. At the time when they were kind of doing this, there was this chaos theory was actually pretty popular. It was an emerging idea at the time. And there's always a temptation to embrace emerging ideas because they're, up and coming, and you think, well, this is everything can be put in this basket. And in fact, that's not what you can do. You shouldn't always do that, or maybe you should never do that. I don't know. It's like everyone wants to do machine learning now. Maybe not. The problem is that chaos theory, although it did explain some of these things, it didn't really give you it didn't match the data very well, and it was hard to put numbers into the models. And so this is one of the things that, you have to remember when you, use a computational model is, can you put numbers into it that make sense? Do they produce results that make sense? At the time, chaos theory was about attractors and things like that. So you'd see these pretty pictures of attractors, like butterfly attractors and things, but they didn't really mean anything. It was hard to interpret. There's a parallel between that and a lot of the dimensionality reduction stuff that people do now with like T-SNE and some of these other methods. But that's an aside. So they didn't go with chaos theory. One of Kelso's inspirations was Hermann Haken. And so this is what was mentioned in the book that we were reading. Hermann Haken is a physicist, a German physicist who had a lot of work in lasers and other types of physics things. So it was very much physical science. One of the things he came up with was synergentics. And this is the idea that things are synchronized, that things have this sort of, that, you have things that work together to form these synergies. So there are things like muscle synergies that you can derive. That's not a physical system necessarily, but it's an interesting example. So there's synchronization, there's how things work together to form this coordination. So this is what was interesting about Haken's work. There was also some influence from Ilya Prigogine, who was a complexity theorist, who came up with this idea of dissipative structures, where you have, like for example, if you have a river that runs through some landscape, that river will bring energy into that landscape. So it will allow for trees to grow along the banks, animals to live there, and then if the river dries up, all that goes away because the energy's gone. And so there are a lot of, the idea is that there are these dissipative structures. As energy comes through, they thrive. When the energy is removed, they die off. So that was another strand. And then there's Rene Thom, who was a mathematician who came up with this idea of catastrophe theory, which is the idea that discontinuities reign in a lot of systems. So, we think of systems as like these smoothly operating things that have this regular behavior. What Thom argued was that a lot of systems, and cognitive systems may be included, have these discontinuities or these sort of catastrophes that happen, and they shape the dynamics of the system. And so, you might have in machine learning, people talk catastrophic forgetting, which is where you have something where things are just forgotten en masse. And so, that, and again, even like in something like cognition, where you have people have, get amnesia or they forget things. That's a failure. So that's a catastrophe. But there are a lot of problems with this theory. It was very fashionable at the time as well. It fell out of favor because, again, it didn't really map to the data as well as it could. So Kelso worked with Haken. They came up with the Haken-Kelso-Bunz coordination model. And so that was a model that was derived from a physics standpoint, but was applied to this problem of dynamical systems for rhythmic behavior. And some of the things they're interested in with this model are the instability of motion. So, if you have someone with a movement disorder, and you can study the instabilities in their movement, how does that relate to normal movement? And then, where you can have instabilities where, people maybe have to adjust to a new environment, or they have some problem that they encounter during motion. So there are all sorts of instabilities. There's noise, motor noise, as they call it, or other types of things that play a role. And then there are these phase transitions. So the kind of catastrophe theory kind of fell out of favor. But what's interesting about catastrophe theory is that it's in dynamical systems, it's still an important thing to have these sort of discontinuities. It's just maybe not the best thing to have it couched as catastrophe theory. So phase transitions are where you have these sudden changes in state. So phase transition, and I've talked about this a lot in my other group, but a phase transition will be like if you have a bivariate function representing a system, you have behavior, and then you have this change in the state. It's a sudden change in the state. So this is a phase transition. So if you think about first order phase transitions in physics, it might be a change from water to ice or water to vapor. All right. There are other types, second order phase transitions, which are more complex. If you're thinking about like a behavioral system, it might be something like what we've referred to in our group as a switch. So there could be a switch between behaviors that you see. But these are discontinuities. This allows for systems to be bistable. So you can have systems switch between one or two states. And, it becomes, it's a nice mechanism for looking at change that isn't like continuous. So this is, let's see, let me move up here. So this is J.S. Kelso here, and he wrote this book, Dynamic Patterns, which is about 30 years old. It talks a lot about some of these concepts in more detail. This is one of the experiments that they did with the motor control experiments, where you move your fingers, you put your thumbs together and you move your fingers either in the same direction or against one another. And if you switch between those two modes, there's like this interruption. So you have to recalibrate your finger movements. There are all these things that you observe, and they're very consistent with this idea of bistability, where you have maybe two states that are stable, but you have to make some sort of transition between them. And so that's where we talk about bistability. We talk about systems that are in bistability. We talk about systems that have two stable states, and then you have to switch between them, and that switching phase is unstable. So that can lead to other changes in the system, or it can lead the system to break down. Um, but this is something, again, this is a model that's derived from physics, and the question is can it map very cleanly to behavior? And for something like motor control, it can, but for something like like consciousness, probably not, because you don't know what numbers to put into the model. That's an important point. So finally, if we want to look at what motor synergies are in more detail, you have these muscle groups in your leg, and when you walk, they're co-activated, and this is by the brain. So the brain is activating muscles, the nervous system is activating muscles to move, and these muscles have to work together to maintain a stable gait. If they don't work together, say if you have a muscle injury, then you can't walk normally. You have a disorder of movement. And so these activations are coordinated by the cooperation, sort of the cooperativity between these muscle groups. And so that's what leads to movement, smooth movement, I guess. There are a lot of different parts of the brain that are involved in this. You have the cerebellum, you have motor cortex, all these other areas, but they send signals downward. And then, of course, if you're walking maybe through like some sort of liquid, if you're walking knee deep through a swamp, or if you're walking against some weird surface, your movements are going to be affected as well, because that environment will give you different feedback, and that feedback will change how you regulate your movements. And these muscle synergies are not, it's not a continuous tuning, although it is in some sense. It's also it also holds that there are instability points. So if you adjust your behavior a little bit, you can do that. But if you have to adjust your behavior in a different way, like in a fundamentally different way that sort of decouples these muscles from working together, then maybe you can't really make that adjustment, and maybe you fall over. And then that's where you get those instabilities. So I talk about all that to say that there's this there are a lot of concepts that we've kind of talked about in the Fuchs book and some of these other things in terms of embodiment that have like some relation to the dynamical systems perspective, some of these other perspectives, and of course also ultimately this physiology that we're interested in. And then that brings us to this idea of reductionism. So, we think about motor physiology or neurophysiology, we think of reductionism. We think of like, what's the cell or the circuit that we want to look at? And what this suggests is that may not be necessarily the best way to study these kinds of systems. But that's the history of studying these systems. But maybe that's not the best way. And, at least not in all cases. Sometimes you want to have a reductionist perspective to, understand like a certain mechanism to decouple things about a mechanism to figure out how it works. But if you want to know how, like, you have, like, behavior, coherent behavior, maybe you need to think about the entire system. And so this is ways to bridge this gap. And I think a lot of the things we've talked about in some of the things we've read in our reading group kind of move us in that direction. But that I think is really useful for some of the other things we do in the lab, like in agents and maybe in some of the other shared interfaces and virtual reality and things like that. So it's very, very cool connections that we can make.
I have a question.
Okay.
How does the concept of criticality fit in?
So criticality is like these points where you have these changes occur. So I don't know if you're familiar with the sandpile model of criticality. Okay. So let me share my screen. I'm going to go over this just because it's probably useful to understand this concept. So criticality is where you have these changes that occur, but they occur as a result of sort of cumulative behaviors. So one of the models for this is the abelian sand pile model, and that's just like a pile of sand. All right, so it's like sand grains. And sand grains are these discrete things that you find on the beach, and they clump together. If you play with sand, the properties of sand. So let's assume that we can make a little sand pile, and we just have these grains of sand that are falling down into a pile. And so there's this pile of sand grains. And we're just going to drop sand grains. Should align things better. We're just going to drop sand grains in this point until we start to get a pile. Okay. And this pile is going to start growing and growing and growing. And we keep dropping grains of sand one at a time on top of this pile. And so eventually what's going to happen is this pile is not going to grow evenly. It's going to grow with a side, and then there's going to be like a top, and there are going to be some discontinuities because the sand grains will fall on the top and then roll down the hill, but it's going to be uneven as to where they roll. And so they're going to be like, if you've ever built a sand castle, you know what I mean. That the sand is, if it's not wet, if it's dry, you can see this a lot better. That the sand has this property where it behaves collectively as a bunch of grains, but then you'll get these rapid collapses. And so that's what will happen to the sand pile after a while, is that you'll hit it with a single grain at some point, and there will be an avalanche on one side or another. So say there's an avalanche here. And that avalanche will occur we can't really predict the interval at which they occur, but they're going to occur at certain intervals. And so what that means is that you have this pile that you're growing piece by piece. And if you think about this in terms of reductionism, we can think of, well, if the sand pile, as we build the sand pile, we can think about it in terms of, okay, we can take individual grains and add up their collective effect on this mound. So we can say, okay, so this mound will grow a certain amount given how many grains I plant. So if I drop 10,000 grains of sand, there will be an accretion of X centimeters, and then that sand pile will grow over time, and we can predict how tall it will be at time T, right? So, but that's not that's not what happens. What happens is you drop these grains of sand, the sand pile grows and grows, and it grows what they call anisotropically, which means that it's uneven as to each side where the sand grains roll down. And then eventually there's this give point where you hit it with a grain of sand at the top, and this whole side collapses because it's unstable and because there's just enough pressure to make it go. So what's interesting about these avalanches is that they're hard to predict their frequency. So, we might assume that, okay, we have these avalanches, that's fine. But let's just assume that they're evenly distributed, okay? So what if we said that these avalanches were evenly distributed? That at every time, we have a displacement, and they're just regular like this. Well, the problem is that's not how these sand piles work. The anisotropic nature of it, meaning that, because the sand grains roll down each side, they roll down in different directions. They don't do it in a systematic way. That sets up these instabilities that are local, and that sets up these avalanches that are not only not easy to predict where they're going to happen, although you could probably look at it and tell, but that they are uneven in time. So what you'll end up with is something like this, And these are the displacements, and this is time. So this is time here. This is the magnitude of the displacement, or something like that. Okay, so so that's and then if you measure this in terms of a power law, sometimes people will take the data and stick it into technique they'll call power law. And the power law is where you look at the frequency of these displacements over time or over their magnitude. So you might rank order this, or it could be time, and then this could be like the magnitude or the frequency of displacement. And you get like what they call power law, which is where the distribution looks like this. It's nonlinear, and that's the important part of this, is that distribution is nonlinear. And it's, so what you end up with only a few very large displacements. So you end up with a few large avalanches, okay, large scale avalanches, and then only, maybe many small avalanches where sand grains get displaced in different directions. That's more frequent. So the more frequent displacements would be here, and the large scale displacements would be down here. And that's what you end up with this sort of sand pile model. So this is a sand pile model. Okay, and that describes, it's just a metaphor for describing these kind of changes, these kind of nonlinear changes, these kind of cumulative changes. And that's, it's a very common, it's a very old model. It's about 35 years old or so. And so people have used that. There are other types of that describes what they call phase transition as well, because you'll have phase transitions from something that's this pile to something that looks different because of this big avalanche. People have looked at other types of models for this, but the sand pile is by far the best in terms of like conceptual understanding. Now, I mentioned before about reductionism. So, we can take a lesson about reductionism from this as well, because you can say, well, the sand pile model is, it has this rate of collapse that's nonlinear, and you have these different magnitudes of collapse and all this. So what if I said, well, if I can just build a sand pile and I can just drop grains and I can predict when these things will happen, I can, that's not a problem. Well, it turns out you can't really predict them in time. They just happen kind of randomly. So they could happen, with great frequency for a little while, and then you might not have another avalanche for a long time, just because of the internal dynamics. And so, a reductionist method where you looked for like some mechanism of each grain being implicated in this avalanche is not going to really work. You have to have this mechanism has to be broad, and you have to say, what is the overarching sort of rule that you have for this? So it's a little bit different way of thinking about it. It's like thinking about the specific interactions versus the behavior of the whole system. And we talked about this in the meeting when we talked about emergence, because as it turns out, this is kind of a lesson for emergence. This is this collective behavior that happens. It can only happen if there's collective interactions that occur over a certain amount of time in a specific context. So if you build one sand pile model and you get some data for it, you say, well, there were these avalanches at these different times. Now I'm going to build another sand pile, and I'm going to start building it. And I'm going to predict these avalanches that occur in this new sand pile from my old data. Well, as it turns out, you can't really predict the times. You can only predict that there are going to be a certain number of avalanches per the size of the sand pile you make. So if you drop 100,000 grains, you're going to see a certain number of avalanches, but you probably won't see that many avalanches. It'll probably be like some number similar, but not the same. So you can't necessarily predict between sand piles. And you build a new sand pile, it's going to have different dynamics. It's going to have similar behaviors, but different dynamics. And so this goes back to like a lot of this stuff with self-similarity, with collective behavior, emergent behavior. So it's a very interesting toy model. They call it a toy model because it's not really something that's relevant to the real world necessarily. But if you think about this in terms of like what's going on with, say, like the brain, they have this model, what they call neural avalanches, which is where they look at electrophysiological activity. They look at neurons that are firing, and they look at they've done this in like culture dishes with these cortical arrays, and they've done this in, I think, rat, where they've measured into a part of the brain and they've looked at the electrical activity. And they noticed that the discharges actually have this kind of behavior where you have like random behavior, and then all of a sudden you have this large scale, like firing, this excitement, So it's like this, it's noise, but it's not like random noise. It has the structure of these avalanches, and it's kind of a semi controversial area. There have been a number of papers on it, but it's relevant to what's going on in the brain. So this is a statistical phenomena, but it does describe this sort of tension between collective behavior and these sort of critical points, and how you can't really predict critical points. So yeah, that's good. Morgan and Jesse, I know you're here. I hope you're able to give an update. I know I gave a really long-winded lecture on that. Okay.
What were you asking for an update or?
Yeah.
I don't know what I kind of missed earlier. I saw the lecture. Yes.
Yeah, I was going over some of the stuff we did in the reading group and other things like that.
Okay. So should I give my update of sorts?
Yeah.
Okay. Not a whole lot to say this week. I had a really nice onboarding session with Shalani yesterday. That was good, and it was cool to also see. As an internal note, it was fun to see where we are since we started the intern program, basically, because we're in a different space now, and it's actually really interesting, and things have kind of, I'm going to use that phrase that's so outdated, it makes me laugh every time. Things have grown legs and taken off in different ways. Like there's the internship program, there's the reading group. But I do kind of think it's time to flesh out some more specific things in terms of either there's cognition futures is kind of rolling along, but there's some room to either put a little bit more into the developmental AI stuff, which maybe I can't tell if it's the right time to do that. There's sort of the virtual stuff, and there's also the tech ethics and society stuff, and I'm not sure where to specifically focus on that. I know Shalani is interested in kind of biopsych stuff, so that could be kind of either some existing things in condition features or potentially Diva worm. And I think I get it. We'll see what she wants to do with that. But I think maybe, particularly in the winter and spring, spring will always be a little bit more, the push for your acceleration of women in computing stuff and the ethics that goes with that. So I think I might look at some specific stuff from We Robot or other things and kind of build a bit in that direction, or really try to get a specific call for involvement for someone to do some tech ethics stuff. But I think it might be a good time to really target some either outside help or just refining some projects with things. So that's just a note or thing on my mind about that. Beyond that, the reading group happened, as we probably know by now. I think we're basically almost up to chapter 4 in Fuchs. It's been interesting I haven't read a lot more of the Kaplan book, but it's come up a lot as sort of a reference point for what we're doing and how like different explanations in neuroscience and psychology. So that's there. And what else do we have? I know apparently Daniela reached out to Plot Twisters a bit to check on some stuff, and I don't really know what the latest is with that. But there's crossover opportunities with Plot Twisters. But right, just to give an update about Plot Twisters, I suppose is mostly just design, like figuring out some of the game mechanics right now. It's in a very like design phase of what they're doing, so it's kind of a limited situation. But there are other aspects of things like how to generate some of the content, or how to generate some of the text, and assessing some of the speech used during the dialogues in the game. So that's pretty much it for me. There's a lot going on, but it isn't quite put into. There's a lot of things that are brewing but aren't yet fully ready to come out of the oven or whatever yet.
Yeah.
I think that's it. If I'm missing an area, let me know. But I think that's most everything.
All right. Well, that's good. Yeah, and I agree that we do need to kind of continually revisit. I think the internship, the sort of the opportunities for different times. So I think that fits in well with like how we revisit some of these projects. I think I was mentioning that before, where we have, things that we want to do, and usually the strategy we've used is to say, there's an opportunity coming up to put something in a venue. Okay, here we'll work on it now, and put it out, and then reevaluate it afterwards. And so that's worked. But I mean, we can also kind of tie this more explicitly to the internship program. I think the spring we get this opportunity to do celebration of women in computing, maybe We Robot, and then in the fall we get maybe some other opportunities to do neuromatch. But the problem is, of course, you want to have like a pipeline. You don't want to just do it like a month before the event. So you want to say like, maybe we have these events that we can tie in later. Like, so, neuromatch, well, we don't necessarily know when neuromatch is going to be always, but it seems to be falling in the fall. Celebration of Women Computing is the spring. So we know that these things exist in time. We can just kind of say, this is something we're going to work towards. So, I mean, we can drive projects forward like that. I think, as for revisiting stuff when the right time to revisit things are, I think, I mean, it's just a matter of the opportunities that are there, people who are available to do work. But I think, now with developmental AI, we've been working on all these little pieces, but there's no, they haven't been put together yet. So that's maybe the next step, is to say, well, we've got all these pieces that we've been working on. Can we put them together in a way that's, sort of a next step? So,
and I think that like at a deeper lab admin and like research project manager level, I think that's kind of I think that is, I don't have my pen here. I think that's sort of the next step, and that's sort of the next structure to add is I think it's time to maybe not fully time, but like the we have a bit of a pipeline as far as certain things, like particularly there's the society ethical tech type pipeline. I think re-robot is something we can consistently attend and go to. I think New York Celebration is. I think Neuromatch, okay. And honestly, like international, I don't know when they're gonna do it next year, but the workshop / conference / whatever, international blank on embodied intelligence. Like that's a really, I think that's my favorite event in a lot of ways. And so I think like those are known things we can do. And there's a bunch of smaller or more specific things that are sort of tangential we can do too. That said, I think it's time to kind of flesh out essentially maybe not a full preprint, but something close to a preprint for like Dev AI or like a position paper or a map paper or I don't know about field finding data, but something like that. I think that's and we can do that. I think I have to finish my own frontier map paper with like sort of implementations. That's something to do, and also I think there's something to there's the Cognition Futures methodology preprint paper that can slowly be started out. And I wonder about that too, in the sense of making should we try to make should there be a preprint or a paper that's specifically about the need for something, or like a range, maybe not like a paper, but like writing a position piece that motivates what we're trying to do, like explicitly, might be interesting. And then like creating an actual preprint or something that says, okay, here's the actual like fruits of our project. And I don't know if that should be two different things or not, or just one big part of like the background of the paper. But getting something more concrete in that area, I think, would be good.
Right.
That might help steer some of our next choices.
So yeah, I mean, I guess like the paper would be structured like you'd have the problem, you'd have a problem statement, and you'd want to really be explicit there because people want to know kind of what you're trying to do. And then, there would be like a need for X. So this is what's missing. So if it's like, you're just saying you want to develop methods for cognitive science, people have done that. That's not. But you say we want to develop methods for understanding dynamical cognition, or like the way that people actually behave or animals behave, as opposed to like this sort of strictly experimental paradigm where we look at like trial by trial, or we do these very contrived setups, and then we maybe go to like, okay, then what's the need for this? Who wants this? And you say, well, cognitive science has had a lot of tumult. It's not really a coherent field necessarily, and people will argue with you about that, but that's something you just have to make a strong position on. And then how do we do that? And so then that's where your methods come in, or your potential solutions come in, or your directions for future research come in. And with like something where we've done some things with it, we can point to those pieces of work and say, these are the things that are needed. If we don't do that, we can still say like, maybe there are potential methods that we just talked about, like some techniques for looking at like complex systems. Is that the answer, or are there other answers? There are missing pieces that a lot of people have actually considered like dynamical systems and cognition. That's not really new. What might be new is like, coming up with a certain technique for looking at some problem, or some maybe new experimental paradigms. That's going to be the trickiest part, is like getting, because you can say like you can do like a sort of a very high level thing and say, well, we need more emphasis on dynamical systems. But there are actually a lot of papers that say that. The question is like, how do we convince people that, how do we guide maybe people to very, innovative territory? It's a very hard thing to do. But that's basically the structure, having that sort of posing the problem, being very explicit as to what we want to do, then saying there's a need for it, and then giving potential solutions or directions. And with something like developmental AI, we have pieces in place. Other people have done work. That's, just kind of a position, but it's also kind of a field finding paper, because we're trying to establish this as a field. And even something with CogSci, with like methods, it's a field finding paper, because you're not reinventing cognitive science. You're basically saying, if we're going to have a debate about whether cognitive science is a unified thing, maybe we can just kind of, maybe we need to guide it towards like methods that aren't scattered all over the place in different fields. Maybe there need to be some methods that are unified between, say, like linguistic approaches and behavioral approaches and, measuring the brain, things like that. But the challenge, I think, is finding that last part is the biggest challenge, because it's like if you state something trivial, people will say, "Well, I already knew that," and that's not useful to people, really. If you just restate the obvious and people have been working on, it's like, well, okay, we're there, we're getting there. You know what I mean? You want to make it compelling. That's really the thing that.
Right.
But yeah, I think like cognition futures definitely. There are a lot of opportunities to say this is unique. A lot of people don't mind map things, for example. Like I just did the mind map earlier. That's not a tool that people use necessarily. At least I don't formally use it. And it's like, well, what's the use of it? And the answer, of course, is like you can take things that are almost like field independent and say, this is something I'm going to put into this. I want to see how these things interact or interrelate, different ideas, and evaluate them. Usually people, will approach this by formulating a hypothesis, testing the hypothesis, and then moving on to the next hypothesis. And then they have a collection of hypotheses, and it's very hard to know what it means. The mind map you do, the kind of like, maybe not a similar thing, but you have like these different sources that you see in the literature coming together, these different approaches. And then, if they're coming together, how frequently they come together, what is the implication of them coming together, what are maybe like future hypotheses we can develop from that, or future ideas that might emerge from that. So if you bring together dynamical systems and like motor control, what's the output? Synergentics, is it something else? Is it, maybe some sort of computational model? There are a lot of ways you can approach that. So I would think, I would think if you're going to do a preprint, to think about things like mind maps, but think a little bit more broadly about it, and not just say, well, we can make a mind map. So we can make a mind map to do this, and this is the use of it. It's a utility. But it's also, like interesting from a methodological standpoint. Can we formulate hypotheses from them? Can we build theory from them? That sort of thing.
There was another, I don't know if I forgot what it was during this. I was trying to write it down, but I couldn't. So they're sort of like, in terms of pushing some what about, is there any talk or discussion or moving forward on a Google Summer of Code paper, kind of like we did last time, but in the sense of, here's what we've done, here are different approaches to this. I know things are kind of scattered. It may not be work as a unified paper the way it did before, but I wanted to ask about that.
Well, I've been thinking about that, and actually I've been reviewing the Summer of Code materials, and we actually have, I actually created some issues from the submissions. So we have now in that repository, we have, let me see if I can put it in here. I need to put the link in the chat to open up this thing. But I think we might still do something. I know that Brian's class is kind of part of this equation because he's, so this is it here. This is the GSOC repository. This is where we have the projects for the this lab. We have two other projects in the DevaWorm group, and that's a different conversation. But I created some project issues here for the project board. So these are short and long range ideas. So we did our projects, and now those projects are complete. They're actually in this repository as submissions. But there were a number of issues that grew out of these. And we had this model during GSOC, which was where they're simple to-dos. So these are organized by like space travel metaphors. So there's an earthbound category, which is like things that are fairly simple to do. There's a moonshot, which is like a nice to have thing, which is like developing some, you might have to develop some tools for this. And then a future directions, which is a really long shot thing where you kind of get, there are different types of things that might take 2 years to implement. So this is what we came up with from our meetings, from our submissions. And so we have these issues now. People can address these issues on this board if you want. But we also have, of course, the open source ethics repositories. So we have 3 different repositories here: ethical regulators, reinforcement learning, collective cognition, and then AI ethics. And they're all very nice tools. Nice sets of tools in here that we can go over. And I every year I have this issue where I have to go through the projects and ruminate about how to approach them. But I think, yeah, definitely, Brian's course they're going to build
Website.
they're going to build a repository.
Yeah.
Where you can find models. And that'll probably play a role into any sort of write-up that we do. So I think maybe like we could do a field finding paper like what we were talking about just in the past here. We could do, maybe like a follow-up for next year's GSOC. That's another thing we have to think about. But, and then, maybe a better thing to do, we have to do something for the open house too. So we want to have like a short presentation on this, where kind of walk through the repositories, walk through the outstanding issues, and then maybe have like something raw to that. Or we could do a field finding paper where we kind of get, present this. Well, we did this with the Bratenberg vehicles for the 3 implementations. And then, we have like why it's important, maybe what the next steps are, how to use, and maybe the next step is how to use these models or demonstrate how to use the models, maybe within the context of maybe different problems. So sketching that out. So like, for example, I could make up a hypothetical community, open source community, and use one of the software packages to address a question or address some issues. That might be useful because, the documentation doesn't tell people necessarily how to use it. It just kind of says, well, you can use it, fill in the parameter values. But like, I think it would be nice to have like a practical hypothetical situation. So there are a lot of ways I would approach it like that. I would kind of like have something where we can like kind of introduce the tools, maybe use them a little bit. It's not like the Bratenberg vehicles paper where there's like a theoretical imperative. So that'll be different. But I think this will be, but I think the first step here is maybe the open house presentation where we can just kind of exhibit these things and some of the issues that have led from them, and then work on the paper after that. And then, of course, Brian's project, of course, when they finish, that would be part of that as well.
Yeah, that all sounds good. I think there's some things to be done here, and I think it's time for me to push some of that stuff forward. And yeah, it is sort of graduate application season for me as well. And there's more to say about that, but maybe not right now. One other thing I do want to note is that it was really nice to introduce people to the lab and be able to use the map that I pretty much made last time. The medium, our medium, which has a collection of posts from interns to like covering math, covering stuff. I still have to put the We Robot post up there, but the NeuroMatch post, like that's a really, really that's really nice right now. And just as people looking at what we're doing in the lab, it may actually be good to make a I may suggest, I don't know how to do it, but just as an idea, I don't know on what website or where to do it, but like as it stands right now, it's a really great collection of things that we're looking at. We have math. We have I don't know if we have anything biology related, but with the neuromatch stuff, we have some of the more exploratory posts, and I think making that could translate nicely either into a more static collection of those articles somewhere, like like an onboarding web page. Maybe we could just make maybe the onboarding guide for Devo Learn. I think maybe we could just make an onboarding guide for the lab too, and maybe mention some of those articles explicitly. Particularly thinking about the forthcoming spring interns and reaching out for more specific things. I think that could be a lab admin project. I don't think I know we've kind of had sort of people want to be like part-time assistant lab managers, but I don't think any of those have really panned out fully. But that's something that I would definitely work on. Anyone interested in building out lab-related materials, maybe we can have a discussion about that at some point. But it was just talking to Shalani yesterday and having everything really accessible on that front page of the Medium was really cool. So it's mostly just kind of a tip to the hat to everybody who's written stuff out and try to put stuff into that format, which is great. But also, as someone who was doing onboarding, and it's funny because I have a friend here in Boston who is in this really long, drawn out onboarding process, and we're kind of commiserating about how even like bigger or more functional organizations sometimes just are terrible at onboarding.
Yeah.
And it's like, oh yeah, I'm well, you know, I had to basically be external IT to one of my friends to figure out what they were missing in a certain sense. And so I had to help them resolve that on our own so they could go back to their IT at one point. It was pretty funny. Anyway, I digress, but the point is things that make the onboarding process a little more interesting, more efficient, and being able to show the stuff that we've created, I think is really powerful and fun. And I know this sounds strange, but as someone leading this sort of hour-long onboarding session with a new intern, it was just like, oh, like boom, 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 boom. Oh, it's really nice laid out. We have all this stuff on NeuroMatch. You know, Brian, hello, Brian. The intuitional post would have the different like interns that were like a little bit more undergraduate level exploratory stuff. And it was all right there. And I think that was just a really cool thing to say, hey, here's our lab. And I don't think Shalani had seen that before. So to be able to put people in the context of here's some discussions we're having, I think that's really cool. So
yeah. Well, hello, Brian. We've just been talking about the GSOC projects, and Jesse asked, what will we be doing to sort of further like this topical area? And so I mentioned your stuff that you're doing in the class, and you also sent some slides along you wanted to do like a 3-minute talk on. So why don't you update us on that?
So the 3-minute talk is for the GSOC it's a contributor day. It's basically all the contributors, or most of them, are meeting up and just talking about their projects to each other. So they said, hey, if you want to talk about your project, you get 3 minutes. So Dr. Back, which I can share. I tried to keep it super simple because, like you were saying, Bradley, 3 minutes, not very long, it turns out. Let's see, I think I have them. But yeah, other than that, I've been doing a lot of work on furthering the project. So here, I'll share my slides, and then that way I can talk about what that is.
Right.
Here's our recursive web meeting, which is always fun. And here's my slides. Can you see them?
Yes.
Work? Okay, great. So this is boilerplate. So This is the first slide, just kind of explaining the project. And Bradley, I thought that your original idea description, I don't know how else to say it, project idea, had a lot of really excellent nuggets in it, describing the project really well. And of course, Nick Ashby's the regulator. And then I was just going to go through each contributor and talk about what they did. I used the photos from Jesse's blog post. So I figured we have permission to use that stuff.
Yeah.
And then I just wanted to give one more slide on the future of the project. So basically just going to give myself about a minute on each of these and just talk really fast.
Okay. Oh yeah, yeah. So the last slide actually, could you bring that up? I didn't catch it.
The last slide is the linchpin.
Yeah, because future of the project. So yes, so you're working on this course, and then that's where you talk about the public facing website. Learning models are always in that logo. Be run based on users' GitHub information, and the hope is to enable members of open source development communities. Okay, yeah, this is definitely good. Okay, good.
Yep.
Yeah. And then we talked about before you came in, maybe we'll want to do something for this open house by the end of the year, and this is a good, I think, start on that. We can maybe expand it out a little bit for that purpose. But then also, Jesse talked about maybe we could write a paper, maybe not a technical paper, but maybe more like a vision paper or a field finding paper where we kind of lay these models out in terms of how they could be used in like practical terms, but maybe also if there's any sort of AI ethics ramifications or hooking into something like that. And even, usability or something where there's some potential for, understanding. So there's open source, there's AI ethics, usability, different areas like that where we have people might need to use these kind of tools for, optimizing communities or, understanding why people do things, behavioral change, although we don't really get into that in the projects, but, people could use them in the future because it's open source. So yeah, there are all sorts of potential things, and writing a paper might be good for that. But we're not really there yet. We have to kind of think out how to do this. So
no, we're not there yet, but that's another thing that I'm working on right now, which is that I talked to Jesse about sponsoring me for some funding through Albany to spend some more time this semester working on more models and more getting the conceptual side of things more focused, at least for my end of the GSAC project, and really, so the kind of trying to make more models or make the ones that I have already work better, or in more effective ways, and then also to start kind of compiling conceptual material in a very explicit way towards a paper. I would love to write a paper. That would be awesome.
Yeah. Okay. That's good. Good stuff. So I'm gonna move on here. Already at 20 after. I want to go through some odds and ends that I've collected here over the course of the week. So let's move some of these things around here. So the first thing is we have this brain behavior and complexity curriculum. I don't know if people have seen that. I know I've talked about it in previous meetings. And this actually arose from some of the stuff we were doing for people to prep for NeuroMatch. But it's become much more than that. And it's become kind of a place where we've put together some resources for people. So if people want to learn about different topical areas, they can go to this website. This is on the Representational Brains and Phenotypes website. So the main website there is this Representational Brains and Phenotypes. So it's here, and this links off of the main webpage. And then this is the curriculum under EDU. So, it kind of talks about, if I want to learn something about different topical areas, we talk about in the meetings, but there are resources online. How do I do that? So, you can learn about computational neuroscience and deep learning. And we have the NeuroMatch curricula in place. So someone can go to one of those places. We have the links here and a description and start learning. This isn't like just throwing people at the material. I mean, we can unpack it for people, but this is just a quick kind of overview if they want to, if they're curious about going to some of these resources. That's definitely, useful. But I would encourage people, if they're interested in an area, one thing you can do as a educational contribution is to maybe take some of these and unpack them. So we've talked about like a slow pod of NMA, which would be interesting. I think people might be involved in that, but also recaps of some of these things. So for artificial life, for example, there's the ISAL Summer School, which is a curriculum that they've made. They're videos that on different topics, and oftentimes, again, with like NeuroMatch, you can get overwhelmed with a lot of these topics. You review like 10 or 20 different topics, and so any shortcuts that people are interested in making for these, that would be something that would be a value added thing on top of this, on top of these resources. So we have these nice free resources. We have these nice resources that have been curated, but if we want to curate them further, that's definitely something that could be done. And it helps you learn the material by distilling it and making it into your own thing. So I mean, that's just something that I bring up because it might be useful. But we still have these topical areas that people can explore: computational neuroscience and deep learning, artificial life, complexity theory. So we talked about complexity theory earlier in the meeting, and there are all sorts of different resources out there. Complexity Explorer, which is sponsored by the Santa Fe Institute. We have these different full-length courses and tutorials that exist, and they're just all agent-based modeling. So there are all these different like sources out there, and the idea of this website is to pull, or this web page is to pull them together in one place. Then we have network science, we have data science and machine learning, we have active inference, and then we have open source education and hackathons, which I've just made a list here, but I might write out a little bit more about them. And then we have participatory education and mentorship. This needs to be updated a little bit, but this largely talks about neuroscience, NeuroMatch Academy. There are opportunities, again, to take what you've learned maybe in NeuroMatch or what you might learn from going to these things and creating different artifacts. So this is like creating a hello world example of something in a collab notebook. It could be something like active inference, because active inference is very hard to understand. It's a very high bar to understanding it. So if you can create like a very simple example of active inference, that would be excellent. It would be an excellent way to do this. And this actually holds true for a lot of the things we work on in the lab. So, there may be an opportunity, for example, to create a hello world of Gibsonian information. Now, we haven't done that because we've been focused on these, writing it up in terms of papers, but it's possible to do that. And I think it would be useful. There are also, opportunities to do things like explainer videos. So sometimes I do that for different topics, go through a topic in about 10 minutes and kind of come up with some, really distill it down to its essence. So these are things that we can do. And this is phrased in terms of the NeuroMatch Academy, but it can be done for any of these resources. So I'm constantly revising this page, and we may actually add in some things to do with our mentorship program and things as well. But I just wanted to point that out just to get it fresh in people's minds. Another thing I'd like to talk about is this, that NeurIPS is coming up soon. And well, it's coming up in December, which is sooner than you would like to think. So this is the NeurIPS website for 2022. And the submissions deadlines are passed. So, and even a lot of the submissions for workshops have passed. So this is something that is not like, we're not going to submit anything to this. But it's always good to attend NeurIPS if you can afford it, or even afterwards, there's a lot of follow-up content that you can check out. And I definitely recommend going to the schedule, looking at what they have. This is, I think, the first week of December. The conference sessions are November 29th through December 1st. It's a little earlier than that. Some of the workshops are December 2nd through the 9th, there's some other sessions earlier. This is a hybrid conference, so I think they're doing it in New Orleans live, but then they're also doing like a hybrid aspect. And the thing I wanted to focus on are the workshops. So they have tutorials and workshops. Actually, the tutorials are interesting because they kind of go over different topics. And just to look at the topics, we have, for example, this one, theory and practice of efficient and accurate data set construction. So we talked about pseudo data, I think, in our open source meetings once or twice. This is, I think, I think they're doing, yeah, they don't, registration required. So I think they may be talking about, a lot of this is like training data for machine learning. They might cover pseudo data, but advances in Bayesian optimization, incentive-aware machine learning, which is, there are different approaches to machine learning that are emerging. Probabilistic circuits, representations, inference, learning, and applications. Lifelong learning machines. We talked about lifelong learning. Actually, we were talking about lifelong learning earlier when I was talking about continual AI, or continual learning. Lifelong learning is sort of another aspect of that. Neurosymbolic programming, creative culture, and machine learning, which I think is like art and things like that. So there are different workshops, there are different tutorials, I should say. Then there are the workshops. And the workshops are more participatory. But again, like I think the deadline for papers is passed, but it's still worth checking these out. There are things like information theoretic principles and cognitive systems. That one looks really interesting. I'm not sure, they have their website here. So this is this is where the paper deadline's passed, but this is basically bringing information theory together with cognitive systems. So, you're trying to understand human cognition, but also improve AI agents and human AI cooperation. That's just one example. There are reinforcement learning sessions. There are different niche topics like gaze meets ML, which is, looking at gaze, which is a topic in neuroscience, visual neuroscience, I guess. We're looking at eye gaze. Has been proven to be a cost-efficient way to collect large-scale physiological data that can reveal the underlying human attentional patterns in real-life workflows. So they do things like eye tracking, which tracks gaze, and that can be very useful for looking at like usability or like how we explore a visual world. And so that's useful for ML. And this is largely about like applying it to ML, but they have a lot of different topics here.
Isn't our RPS predominantly in-person based this year, or is there a virtual-ish component?
Well, yeah, there's a virtual component. I'm not sure how it's actually going to be like virtual versus in person, but I think it's supposed to be hybrid. And as we've talked about, there are different ways you can do that that are good or not, not so good. But we'll see. I imagine they won't make it like they're going to make it decent. I would imagine because they have a good track record of doing that, but we'll see. There's the shared visual representations one, which is ongoing. They've had this for years. New frontiers in graph learning, which is about sort of graph neural networks, which is something that in the EvoWorm group we did our GSOC project on that. Like this website looks nice. This is the overview of graph learning. So graph learning is now a new subfield of machine learning. It's focused on developing novel model architectures, theoretical understanding, scalable algorithms and systems, and just kind of working between graphs and learning graphs, which are actually important for computer science representations. So if you build a representation of a program or something, it's graph. To learn graphs of like real life systems makes it easier to build programs and algorithms and things like that. So this is really I think this is really a nice sort of. I like the direction of graph neural networks and graph learning, and I think it's really interesting applying that to ML and deep learning and things like that. So they have graphs in the wild, which is where you're learning graphs from data sets and things that don't have an explicit relational structure. So a lot of data in the world that we encounter doesn't really have a relational structure. In other words, it's unlabeled. And so then that's one thing that they're looking at. Like, looking at graph learning is different from other paradigms, which is true because we haven't traditionally thought about graphs in machine learning. And then, what can they do? What are new capabilities, novel applications? And then just graphs in machine learning in general. So how do you approach machine learning problems that we know of that are sort of canonical problems using graphs? So that's nice. I like that. It's going to be interesting. And then I think, the rest of these are just kind of, you can check these out on your own time. There's just a lot of them. You might attend them. You might check out what happened at them later on. But definitely try to stay sort of abreast of the different developments in these fields. So that's what I wanted to talk
The
about.
workshops look really good. I might try to attend some or finagle my way in somehow.
Yeah. So that's good. Any other comments or questions about that?
I'm really excited to see this because I've been doing a lot of graph-based research lately in one of the labs I'm in, and I think I've mentioned it before.
Yeah.
But what I find really interesting that I hadn't heard about before I started doing this work was the idea of using a dictionary. Has anybody else heard about this in machine learning? Other machine learning math nerd people? Ever heard about this dictionary translation thing? So I think the basic idea is that you use you make a Fourier transform graph dictionary that basically what would it be called? It almost like normalizes the signal so that by putting a time series and a graph representation next to each other and then filtering them both through this dictionary, you can kind of figure out what the larger patterns are.
Okay.
So I'm really excited about graph. I agree with graph. The graph frontiers are the most exciting frontiers.
Yeah. Yeah, I mean, that's a common thing in bioinformatics is to use dictionaries for different things, especially like DNA analysis, where you have like a sequence and you have to map like higher order structures and sequences to different things. They use dictionaries a lot for that, and that's just like a structure in Python, but you can use it more generally as a data structure to build things. So it's interesting. So Morgan has let's see. Actually, let me go to the chat here. Morgan said certainly dictionaries from JTFA, but the graph connection is new to me. And then Amanda said Steve Brunton talked about using a dictionary in one of his data-driven science videos. So yes, definitely there's a lot of use of it. I don't know what the application rate is in graph applications, but that's why we do these conferences and research in general, right? So Morgan actually had some comments earlier. Good to know about this. I love the Star Wars image on the curriculum page. Oh yeah, the one from the learning something new every day. Yeah, it's nice. Arena Higgins also. Yeah, that was the artist of that image. Brian put a archive paper in the chat, and this was
the paper for the typical graph signal decomposition paper that describes how to use dictionaries and graphs to decode time series based graph information.
Yeah, there it is. Okay. Yeah, that's Maxwell McNeil. Yeah. So yeah, that's great. Thanks for that. So I want to talk just very quickly about the different submissions that we have. We have our submissions document, and that is, I haven't updated it very much since last time. I've put in some different, this is 21. So 22 is here. I haven't updated it very much. I've put some things in. But again, if we want to update this, we're kind of at an inflection point for conferences. We've kind of finished up a lot of the conferences for 22, and we're looking forward to 23. So if we have things that we want to mark on our list that we want to target, please put them on. I guess I could put some new ones on. So the things that we're looking forward to in 23, and I'll share my screen again to kind of get into that. So one of the things is the EI workshop, and I think we may have.
Yeah, I was gonna
mentioned
say
this.
like if we maybe like make a I don't know separate space for it or something, but the AI workshop, your celebration of women in computing, come to mind.
All right. I mean, I'm just putting these as kind of list items here, list holders, but like that, these are things we don't know what the deadline is, but we can kind of guess. I mean, this is April-ish. When is New York Celebration of Women in Computing? Like May?
It was early April typically.
All right. I don't know. Neuromatch will be probably later in the year, but I mean, that's not something the reason I'd like to put these on here is because I want us to think about what we want to put in place and, especially if we're looking at preprints or like the EI workshop, it's like a presentation, but it could also be a preprint later or a conference paper later. Just to think about some of these topics because it's easier to come up with things that are really good if we have something in the working towards something, not just slapping it together at the last minute. So I didn't want to I want to make sure that we stay on top of that. So again, if we have things that we want to put in there, we'll just put it in and kind of plan a little bit longer term for that to hit those targets. And again, I mentioned the open house. I'd really like to see something maybe by the end of the year. If we can't do that, we can probably put together some things. And what'll probably happen is at least it'll be like something on YouTube where we have video recordings of some different talks, some different like overviews of things, maybe like a end of the year session where we talk about what we've done this year, what we'll do next year, and then some of our projects. So it'll come together. And then if people want to really do something on some of the projects ongoing, that's fine too. Maybe more in-depth things. So, if it's like a philosophy initiative or like some of the computer science initiative stuff, it'd be great. And I know like with the class that Brian's leading class project, that, sometimes you don't know what that looks like until the end. So, but, it'd be interesting to see what that's going to look like. And that'll be like part of that paper as well. So.
Yeah, I wanted to ask also, is there I'm feeling like for my own brain at least, I need like a list of what's going to be happening with the open house or a place to kind of say, oh, I want to do this thing. And then I put that on the list and then me and everybody else knows, hey, we're going to do this. And then that way, if it's like, oh, actually, could you do this project instead? Then we can talk about it really openly. But I feel like that would be really helpful, at least for me, for planning, because I feel like I keep hearing about the open house, and then I'm like, but when is it? And what's happening? And what do I need to do?
Yeah. Well, I mean, yeah, we don't really have our time set yet, because part of this is getting things in a row, and part of it's finding time for it. So it's kind of like, it's a moving target. But I have a spreadsheet, set up for it. But we'll revisit that a little bit more in depth next week.
We previously discussed this. This was, I think, a couple weeks ago.
We do have a notion for this. So I don't know if we link to the, but this is like, okay, so this is good. We can actually go through this. So we have our potential projects, our papers, our highlights. So this is really like, the possible space of things. And again, like I said, people want to commit to something, it'd be great. If, I don't want to have people commit and then not be able to find the time for it. So maybe a better way is to like kind of revisit this and see if people are,
I think the next step is basically actually filling out the schedule. Like we could have. I think there was actually another. I searched for this. Is it? I don't know. Well, I guess this is it. But I think
yeah,
like making specific, like, oh, I want to do this. Like I'll be doing a methodology thing, and there's the overview stuff, and if I think, was it Ankit with a switching theory paper?
yeah,
But they kind of expressed interest at the time for like presenting their paper, like or something like that. So kind of just knocking those things out. And I do think there's something where it could be like, essentially neuromatch-ish, where we just like record small flash talks, and like we could stream them. They could be pre-recorded, and then we do like at NeuroIPS they actually do like you have a pre-recorded talk, and then the author will just be there to kind of answer questions or whatever. So it'd be something like that. So yeah.
yeah. Well, I think that would be great. I think Brian, like what you've done there, you're doing for your GSOC presentation is probably a good starting point for like what we do for the GSOC projects from this summer, and then the project you're working on. So we just maybe flesh that out a little bit, and then we record it, and then we have that set up. And maybe we wait until we get the SAT website up and running too. So we can have everything like see it. We don't have to say this is in progress. We'll just show maybe like a little bit about like how it works, just a little bit. And then those sorts of things are useful because it helps people get into it. Like I see this thing and it's theoretical, and I'm like, oh, that's nice. If I actually have a pointer to like maybe how to use it a little bit, or that would be good too. And then a lot of this is like in terms of the updates for people. It's up to you how you want to structure it. If you want to structure it as like just kind of recapping where you are, kind of do an outline where you have 2 or 3 things that you want to hit. I wouldn't like overwhelm people with information. It's just like a short update, like this is what's going on in this area, just to give people. And this actually fits into the onboarding stuff too, because again, it's like the blog. It's a very compact way to like say this is something you can become involved in. I might try to prepare a version of something to give people a template, if that helps, and then maybe that helps people, you know, do something. Because I mean, I want to model good behavior, but I also want to have like a. It's very hard to really kind of convey, what the best practice is for that, because it is tough to do these like shorter presentations where you're trying to be effective and trying to present things. But I'll try to work on something soon here. Get it off the ground so we can have like something to work from. And if you think we need to have a template, let me like a slide template. Let me know. I don't think we're going to have a huge number of people doing their own projects, but I think if we can like find a way to make this easier to do, because I really want to hear from people and what they're doing. And yeah.
I do think something like a template helps for people who might otherwise feel kind of like, well, I don't really know what to say here. Like if they have a template, they can just go, oh, that's part of my project. Oh my god, I have one of those. Oh, an abstract. Oh my god, I have one of those too. Like it makes it so much easier. It's like you're walking down a path instead of using your machete to cut through the brush.
Yeah, the lab machete.
Yeah, the lab machete. I do have a machete, but too far. Outside branch. Yeah, no, this seems great. And I really like the idea of the open house existing on YouTube in kind of a decentralized, open way, the same way that the lab is. I think it's really nice.
Yeah. All right. That's good. Thank you. Yeah, I'll do these updates. Maybe next week we can get a little bit deeper into the weeds without the machete. Just um, yeah. So Morgan, are you able to give an update, or do you want to give an update, or I don't know what you've been up to this last week? Okay, not much this week. That's okay. All right. So I just wanted to make people aware that our Slack is, we're gonna have like a bit more constraint on what we can do, because it's like now we only have 90 days of availability for messages and things like that. It's just what Slack's been doing. So I've actually been archiving Slack. So we have the archives, and they're actually going back to 2017. So actually, I have a lot of that material. I'm going to try to make it available in the cloud so we can go back to it. But just to let you know, it's going to change. Like things, you may not be able to find certain things that you had previously been able to find. So, but we do have archives. So all that stuff will still be available, just in a little bit different format. Yeah, Slack went through an identity crisis. Like they're trying to, I don't know. It's not, and it's, I don't know. We'll see. So Morgan said, not much this week. Lots of events next week. I am leaving for Kenya. So, well, yeah, have fun in Kenya. That'll be nice. Yeah, harmonic structure function papers were great to see. Yeah, definitely. Yeah, for those, I think Brian and Jesse weren't here for the first part of the meeting, but we did some review of some of this dynamical systems work in neuroscience, and yeah, especially with respect to synergentics. So, Brian, if you want to check out the recording at the first part, I do this bit on that sort of stuff. Yeah. Well, that's great. Thank you, Morgan. So yeah, now we can get into the readings now. So our readings. Oh, my weekly Neurotech X announcement is a list of weekly events. Okay, yeah. And Neurotech X, they have a Slack. I just joined the Slack on that. And if you're interested, you go to their website and they have a link to the Slack. So yeah, good. So yeah, Morgan's very active in there, in that Slack, and he puts in like different things, and yeah, it's always good stuff over there. So yeah, I'm gonna go onto the papers now. Let me share my screen, and a couple things. Well, first of all, there's this interesting thing I found on Stable Diffusion and VR. So we talked about Stable Diffusion before. It's this text-to-image prompting software. It's like you can generate nice images, generative model that generates images from text prompts. So, there's a lot of cool stuff you can do with it. You can actually run it on an M1 Mac or an M2 Mac. So, there's hardware you can buy now that isn't a supercomputer to run these things on. But this person, Scotty Fox, they basically are trying to do Stable Diffusion and create virtual worlds around it. So this is like, exploiting this latent space where you're trying to generate images, but you're doing it in like a room, or you can navigate around these images. So this is one example they put up on Twitter. It was like a video here. I don't know if I can run this. I can't do that. But it's just basically they're moving through a room, but this whole room is being generated by Stable Diffusion images. Then there's another one here where you have this. This is another room where they're doing a similar thing in a different space. So you're basically, trying to navigate a space, trying to, draw from like 360-degree video, which is another tool that you can use in generating virtual worlds. So that means you put a camera like at different angles. So you take an image, from your point of view, and you move 360 degrees around. You capture that whole space, and then you render it for the user. So I may be sitting in a room here, and I might have a video where I could rotate around and see the entire room, and that's a virtual volume basically. And then you could use a generative model in this case to generate different versions of it. Generate a weight from the weight and space, generate some sort of visualization, some sort of virtual world. So that's I just wanted to point that out because I'm always impressed by some of this stuff that's going on with Stable Diffusion and some of these other VR systems and some of these other machine learning systems. We have something in the Slack here too on, I think it's in Data Science ML. There was some discussion of some of the some new machine learning models. There was a paper on Poisson flow generative models. There's something on this faster matrix multiplication algorithms with reinforcement learning. AlphaZero dropped a couple of papers in that area this week. You might check that out. There's some interesting things on transformers coming out. So there's really a lot of activity in that space, and it's always interesting to see what people are doing there. Another thing I wanted to point to, and this was something we talked about at the end of last week, and this is for Jesse's benefit because he wasn't here at the end of the meeting last week, is this paper, Topics in Cognitive Science. This is the Chris Elias-Smith paper on the complex systems approach. So we talked about complex systems earlier, and we said that you can use, say, like dynamical systems to model cognition. And this is a paper, this is actually a special issue of Topics in Cognitive Science that has, like, it's more or less a critique of this approach, or maybe, critically evaluating this approach. So, they bring up a lot of Shimero. So that's interesting. I just thought Jesse might like this paper. I'm looking here, so I don't know where to start with it because we talked a little bit about it last week. So I don't know where to start with this. I guess, let's see. He talks about a little bit about complex systems and maybe how they're kind of a problem. Maybe the discussion surrounding it is the problem, not so much the approach. So he talks about some of the things. So there's a revolution on the horizon. It comes in the form of complexity theory mixed with dynamical systems theory, coupled to the observation that cognitive systems are extended brain-body environment systems, resulting in this is jargon, emergent power law relationships. So we talked about that with the sandpile model a bit, but this is again something that people talk about in the literature. Identifiable by multifractality, which is another thing they talk about in the literature. So this is like one of the problems with this approach is that there's a lot of jargon, a lot of concepts that maybe aren't familiar to typical information processing approach to cognitive science. So the authors of the 4 target articles, so there are 4 articles in this special issue. They're, different suggestions, like moving beyond the formalism of information exchange, succeeding at circumventing paradoxes that plague cognitive science. And so those are things, shedding new light on paradoxes and promising conceptual methodological advances, otherwise not available. So it looks like, they have like this sort of agenda of kind of maybe augmenting this information processing approach to cognitive science, or maybe even supplanting it, because there are a lot of paradoxes in cognitive science. I don't know if they mention the paradoxes here. Let's see. When challenged on some of the more contentious claims during the review process, some authors provided clarifications like, we mean paradox in the broader sense of defying intuitions. This may seem a minor semantic issue, but paradox means a seemingly absurd or self-contradictory statement. Not surprising. So, there are ways that people have defined these issues in the literature. Example paradoxes such as rapid, ultra-fast perception are not inconsistent with, nor do they obviously challenge current perceptual theories. So they give some lists here. So they're not even surprising. So I think Elias Smith kind of points out that a lot of these critiques of cognitive science aren't necessarily, it's not that they're not valid, it's just that they're not really, they're sort of maybe jargon driven, or they're sort of concepts that don't necessarily need to, you don't really need a paradigm shift. So why does this matter? Because I believe it is symptomatic of a deeper problem with many discussions surrounding complex systems analysis. This symptom is seen many times over in the 4 papers under discussion. The symptom is rhetorical excess. The problem is a lack of a useful novelty. So we talked about the novelty of things with respect to the vision paper, and that's one of the things that it always comes out in the literature, when people evaluate papers. Is this really something that's new, or is this something that's been talked about before? And when you can make a really focused sort of contribution, or you point out something that's never been pointed out, it's nice, but a lot of times you always stumble against this thing where people have come up with this criticism before. So there are some early papers. Port and Van Gelder is a nice one from '95, where they talk about dynamical systems and complex systems theory. The case is usually overstated and underspecified. So so there are a lot of people have been worried about the dynamics of cognitive systems, but a lot of times these things are really not specified as well as they could be. And so we saw that earlier in the meeting, where I talked about importing physics models to look at dynamics of cognition. You have to have the numbers, you have to be able to take the numbers, or the measures, I should say, and put them into the model and, have it make sense. If you just throw in a conceptual model and say, well, we can map numbers to it and we can get pretty patterns, that isn't really solving any specific problem. So, there are issues like that. There are also a lot of rhetorical issues where you say, well, something is self-organized, but that doesn't really mean anything, because it's well, what does that mean? What's the implication of that in the brain and in behavior and all that? So, so again, you have this issue of underspecification. Yes, there were models that used differential equations, but these were piecemeal, vague in their relation to measurable properties of the system, and typically not very cognitive. Furthermore, we already have models that were sets of differential equations, which fit perfectly well with the talk of computation, representation, and information processing, some of the main targets of CSA approaches. So things are, people have solved maybe some of these problems in computational neuroscience, Rao and Ballard is an AI paper, or AI-oriented paper. Olshausen, Anderson, and Van Essen is a computational neuroscience paper. Hopefield is computational neuroscience. We have models from other areas that could fit perfectly well into mainstream cognitive science. But these aren't things that people typically look at. They want to reinvent the wheel. So this is the kind of thing, this is the kind of criticism of the complex systems approach. So again, terminology should be sparingly. We shouldn't just create new terminology and think that we're changing our conceptual world. We can have different types of terms that we use. So no doubt our notion of cell is much different in biology now than it was 100 years ago, but it's still a central theoretical element of our biology. This is true of many theoretical terms: mass, heat, neuron, species, atom. The list goes on. But sometimes notions do get thrown out, like phlogiston, which was an old idea about, it was an old scientific idea that got overturned. It was sort of an agentive thing in I think it was in chemistry, because they are not part of a theory that captures as much data as a competitor. Is representation more like cell or phlogiston? So the idea is that, thinking very meta about representations, when we measure something, it's a representation of that phenomenon. And if we can capture that phenomena well, we can say like a cell, which we can map to different parts of a system and measure it, and then have a nice representation of that thing that we want to understand. That's what we want to do, and it's a representation like we might find, like in a computational program or something. So if we can optimize that representation and make it useful, that's all the better. So that's some of the critique that they're making in this paper. So there are a lot of I think it's a pretty interesting paper for looking at like cognitive science and sort of the paths that cognitive science has taken and maybe things for the future. So Amanda had to leave. Thank you, Amanda. Yeah. So did we have any thoughts about that, or? I know, Jesse, I wanted to bring it up for your benefit.
Well, yeah. Thank you very much. I have not seen the paper, so I'm sure it's somewhere, or you can post it somewhere.
Yeah,
but
yeah.
that looks like an important paper for pretty much the whole cognitive conditioned futures effort. So yeah, thank you for going over that again today.
Okay, so that's that paper, and I'll post that. Let's see. So let's see. Let me go into these papers here. This is something called ecological intelligence. It's kind of an interesting set of papers I found on. So I think we've talked about ecology and how ecology is actually pretty mathematical. It's a study of ecosystems and things like that. And there's an area called behavioral ecology, which is where you look at the behavior of animals in an ecological system. So if you're looking at like feeding behaviors in squirrels, that's behavioral ecology. And there's a whole set of theories and things that come from that. This set of papers kind of looks at that as like something we can transplant to artificial intelligence and allied areas. So this paper is enriching behavioral ecology with reinforcement learning methods. And this is a group of people. I think Bartow is from the reinforcement learning area. Franquise is a behavioral scientist. And so they kind of work on this idea. It's kind of bringing together behavioral ecology with reinforcement learning. So reinforcement learning, of course, originated in like animals like rats and mice. And, it was actually a common part of behaviorism, which predates cognitive science. So it's this idea where you present rewards, you can enforce behaviors, and that's something, you can have like associated stimuli, and you can reinforce, you can achieve learning through reinforcement, basically. But this is enriching behavioral ecology, which is quite a different area. So the abstract reads, this article focuses on the division of labor between evolution and development in solving sequential state-dependent decision problems. Currently, behavioral ecologists tend to use dynamic programming methods to study such problems. So if you're using dynamic programming, it's basically a technique in computer science where you're trying to optimize your program using different sort of mathematical or numerical techniques. These methods are successful at predicting animal behavior in a wide variety of contexts. However, they depend on a distinct set of assumptions. So there, a lot of times you like penalize certain solutions and you reward other solutions. So it's similar to reinforcement learning, but it's a different paradigm and it's very piecemeal. It's not really something that is, it doesn't have this biological aspect to it. So here we argue that behavioral ecology will benefit from drawing more than it currently does on complementary collections of tools called reinforcement learning methods. These methods allow for the study of behavior in highly complex environments, which conventional dynamic programming methods do not feasibly address. In addition, reinforcement learning methods are well suited to studying how biological mechanisms solve developmental and learning problems. So this is, reinforcement learning is very close to a lot of these problems because it already comes from that area. It's just, they're using it in computation now. So For instance, we can use them to study simple rules that perform well in complex environments, or to investigate under which conditions natural selection favors fixed non-plastic traits, which do not vary across individuals. Cue-driven switch plasticity, which are innate instructions for adaptive behavioral development based on experience, or developmental selection, the incremental acquisition of adaptive behavior based on experience. If natural selection favors developmental selection, which includes learning from environmental feedback, we can also make predictions about the design of reward systems. So this is something that Franklin's actually, I think, does some work on critical periods. So that's where they're doing this idea of developmental learning and things like that. So it's kind of interesting how they're applying reinforcement learning to that area. So each organism faces a host of adaptive problems. These range from short-term problems like foraging under the risk of predation to long-term problems like allocating resources to growth, maintenance, and reproduction. So, this is where if an organism is developing, it needs to allocate resources to its growth so it can grow bigger, or it can maintain its phenotype, or it can reproduce more offspring. And so sometimes in a lot of cases, energetic constraints are such that they have to, that sort of, sometimes you invest your energy in reproduction. Sometimes you just can only invest your energy in maintenance. Sometimes you can also invest your energy in growth. It's kind of an interesting problem, and it's not like a conscious problem. It's just like an optimization problem that the organism encounters. Solving an adaptive problem entails generating an adaptive phenotype, ranging from behavioral repertoires to developmental patterns. In behavioral ecology, an adaptive phenotype refers to one that improves fitness relative to other phenotypes. So here we focus on processes that solve adaptive problems over two timescales, evolution and development. So they're looking at the lifespan, development of the lifespan, and then evolution. So some of these issues of allocating resources and foraging under predation, they relate to both of these timescales. So, this is an interesting application. They're also looking at sequential state-dependent decision problems, which is really something we also look at in cognitive science. People have turned to a number of different approaches to this in terms of models. Optimal control theory being one, where you try to optimize the problem, but that's not really satisfactory a lot of times. So, if you consider a bird that needs to find enough food each day to survive the non-breeding season, birds vary day to day in their energy reserves, based in part on their previous foraging decisions. Reserves increase through food consumption and decrease through metabolic expenditure. If energy levels drop below a threshold, the bird dies of starvation. But energy reserves, they can't increase infinitely, or they don't continue to increase indefinitely with consumption. At some point, the fitness benefit of additional reserves is outweighed by the cost. So this is where you store maybe fat, but there's a cost of storing your energy as fat. And so this is something that is, you can solve it with dynamic programming or with optimization, but it clearly becomes a problem of, multi-objective optimization, and then it becomes too hard to really solve, or it doesn't get solved in a way that's satisfactory. So, there are a lot of ways we can approach this. They talk about Markov decision processes, and so people can use that. They can use stochastic dynamic programming methods. Then they can use reinforcement learning. So this is where they get into reinforcement learning and talking about the suitability of this approach. So that's that paper, and this is applying it to behavioral ecology. This paper, though, they talk a little bit about sort of the free energy principle and how you might, look at the anticipating brain. So this is from Synthese, and the title of this is "The Anticipating Brain is Not a Scientist: The Free Energy Principle from an Ecological and Active Perspective." So now they take this ecological perspective, and instead of using reinforcement learning or some other optimization method, they're looking at this in terms of predictive processing, the free energy principle, and active inference, that whole set of tools. So the abstract reads, in this paper, we argue for a theoretical separation of the free energy principle from Helmholtzian accounts of the predictive brain. So the predictive brain, Helmholtzian, just means like entropy or optimizing energy. So I guess what they're saying is that they want to separate these two out, or at least the Helmholtzian account. The free energy principle is a theoretical framework capturing the imperative for biological self-organization in information theoretic terms. The free energy principle has typically been connected with the Bayesian theory of predictive coding, and the latter is often taken to support a Helmholtzian theory of perception as unconscious inference. If our interpretation is right, however, a Helmholtzian view of perception is incompatible with Bayesian predictive coding under the free energy principle. We argue that the free energy principle and the ecological and enactive approach to mind and life make for a much happier marriage of ideas. We make our argument based on 3 points. First, we argue that the free energy principle applies to the whole animal environment system and not only to the brain. So they're actually looking at this in a broader context, not just the brain, but the entire body. And actually the animal environment system. So it's the phenotype, the environment, and the brain. Second, we show that active inference is understood by the free energy principle is incompatible with unconscious inference, understood as analogous to scientific hypothesis testing, the main tenet of a Helmholtzian view of perception. So this is actually where they look at this sort of inference analogous to scientific hypothesis testing. So it's kind of like you come up with a hypothesis, you have to test it in the real world. This is not, they want to move away from this idea of perception. Third, we argue that the notion of inference at work in Bayesian predictive coding under the free energy principle is too weak to support a Helmholtzian theory of perception. Taken together, these points imply that the free energy principle is best understood in ecological and enactive terms set out in this paper. So this is a pretty deep paper in this area. Like, you have to understand a lot of the free energy principle jargon to really kind of get this paper. But I think, they kind of, the idea of this paper is like, how do we approach dynamics? What is the model we want to use? And what's the best way to look at this? And they actually look at this sort of, these coupled organism environment systems. And when they do that, there are a lot of consequences to that. Not least of which is that there are these models that we have of perception that are violated by just simply looking at it in a different light. And so this is sort of the point of this paper. So they take this ecological approach and they come to different conclusions about this. So the Helmholtzians actually isn't so much to do with entropy as it is this idea of perception as unconscious inference, whereby the task of perception is to infer based on top-down knowledge structures the current causes of sensation. So this is where we have this idea of, a very deliberate way of looking at perception as something that's inferential, but it's also unconscious. So that's his paper. And then the third paper is this Ecosystems Path to AGI. So this looks like something that's very visionary. And this Ecosystems Path to AGI is, kind of related to what we've been talking about before, except it uses ecosystems as a way to sort of couch AGI, because we think about this in terms of simulating a brain. It may be in a jar, maybe something loosely embodied, but this is more looking at the ecosystem aspect of it. So the abstract reads, we start by discussing the link between ecosystem simulators and artificial general intelligence. So they're kind of linking those two ideas together. Then we present the open source ecosystem simulator EcoTwin, which is based on the game engine Unity and operates on ecosystems containing inanimate objects like mountains and lakes, as well as organisms such as animals and plants. So now they're taking this, they're using like a video game engine, basically a physics engine, and they're actually building a world where they have different, deliberate things in the world, like mountains, lakes, so, you're simulating different things that are outside the body, even. Animal cognition is modeled by integrating 3 separate networks: a reflex network for hardwired reflexes, a happiness network that maps sensory data such as oxygen, water, energy, and smells to a scalar happiness value. So there's this basically all these things sort of are, come down to this happiness value. And a policy network for selecting actions. So we're kind of coming back to reinforcement learning here with the policy network. The policy network is trained with a reinforcement learning algorithm where the reward signal is defined as the happiness difference from one time step to the next. So the idea here is that the correct policy is based on what makes the organism most happy. And this happiness is derived from this ecosystem that they're modeling. All organisms are capable of either sexual or asexual reproduction, and they die if they run out of critical resources. So again, we see reproduction as an aspect of this world as well. We report results from these studies with EcoTwin, in which natural phenomena emerge in the models without being hardwired. First, we study a terrestrial ecosystem with wolves, deer, and grass, in which a Lotka-Volterra-style population dynamics emerges. So Lotka-Volterra-style population dynamics are basically a predator-prey model, if you're familiar. We talked about this in some of the agent-based modeling that we were doing this summer, where you have a predator and a prey, and the predator consumes prey, and then the population of prey decreases enough so that the predator runs out of things to eat. So the predator's population crashes. That allows the prey's population to rise again. And you have this cycle that goes on, maybe indefinitely, where you have fluctuations in those two populations. So you have things that are interacting where the population is fluctuating, and there's an interaction is key to maintaining that relationship. So they're doing this terrestrial ecosystem has the dynamics of an ecosystem. Second, we study a marine ecosystem with phytoplankton, copiopods, and krill, in which DL vertical migration behavior emerges. So this is where things move up and down the water column, and there's this vertical migration, and so this actually affects these ecosystem relationships. Third, we study an ecosystem involving lethal dangers, in which certain agents combined RL with reflexes outperform pure RL agents. So these, when you have RL models with reflexes, or this reflex network, it actually outperforms a pure RL agent, which doesn't have any of these. So what they're doing in this paper is they're combining embodiment, which is this reflex network, a happiness network, which embodies the ecosystem, and then a policy network, which is basically a selection mechanism. And we saw that in the first paper to build this kind of AGI, or what they claim is AGI. I don't know if it is or not, but they talk about arms races, which have a relation to Lotka-Volterra systems, and they're looking at these interactions between agents in this ecosystem. So this is a really interesting paper as well, because it kind of defines a lot of these things computationally. I mean, again, it's a reach, it's a kind of a visionary thing, but this is an example of their 3-species predator-prey ecosystem. So they're actually modeling the organisms in a virtual environment. They're looking at the population dynamics, which is where there's a lot of fluctuation over time, and then they're able to use reinforcement learning to derive policies based on this. So there's a lot of interesting stuff in this paper. But I think putting those together, you can see that there's a very strong case to be made for using ecosystems, or at least that metaphor, to look at these sort of intelligent systems. So we have, let's see, where are we here in the comments? I'm looking at the chat, and I'm trying to find out where we are. So I think Jesse's thumbs up. That was for the paper, the Elias Smith paper, yeah. Okay. Then I did it with invertebrates. That's Morgan. Yeah, RL with invertebrates. Yeah, yeah. There's a lot of stuff with like sea slugs that they've done with like conditioning and things like that in the lab in memory. It's interesting. You did this some invertebrate work with RL. Then Brian said, "Love this. Excited to dig in more. Great weekend." Ecosystems AGI paper is relevant to a discussion I'm going to have soon with someone about AGI. Curious to read it. That was Jesse. And
Yeah, actually, Sonia Joseph just mentioned something about discussing AGI, but particularly without referencing, like trying to talk about AGI discussions and AGIs, like thinking about them in terms of like ways that aren't centered around like Nick Bostrom or Yudkowsky from Less Wrong, rationality stuff. So I'm curious. I'm not sure if I'm not quite sure what's going to happen with that, but we'll see. This paper is very, very timely. She was talking about curriculums, and it's funny because I actually went to Twitter to post a screenshot about the curriculums that you mentioned earlier, like the brains and stuff curriculum.
Yeah, yeah.
And then immediately underneath my post is like, oh, like so somebody's thinking about this stuff. So we'll see.
Okay, yeah. Yeah. Then Morgan said I was doing it with crabs. That was the invertebrate RL. Then Eco Twins work reminds me of Richard Watson's work. Yeah, Richard Watson is a interesting person. Yeah, we'll make a note of that for maybe another week. But yeah, that's great. At Southampton, yeah, he's at Southampton. All right, so I think that's it for this week. I think it was a pretty good meeting. Covered a lot of territory, so we'll be on the lookout for some of the stuff for the open house. I'll try to make a template, and we'll keep discussing that and move forward on it.
One other thing, before I forget, I mentioned this one of the meetings earlier. I don't know if it has to be a formal meeting yet, but I think having a discussion or a meeting either about, I don't know if it should be specifically dev AI stuff, but sort of like a meeting that's like, all right, let's figure out kind of what we want to crystallize a bit more, whether it's dev AI or something else. I think it might be dev AI, but like I don't know, I'm not sure when, maybe the next couple of weeks, but I think we should have like a discussion that's maybe not in this meeting about that, just to kind of like gauge where we're at, where we can go into that, because I feel I want to do that, and it will encourage me to prepare some more stuff for that. I feel like I have a lot of things to prepare for a lot of stuff, like kind of administratively right now. So
yeah.
I'm saying this mostly for myself, but just like I think it'd be good to have a separate discussion about what we're doing with that. So yeah.
All right. Well, that sounds good. Yeah, we can set that up maybe in the next week or two, and then yeah, we can figure out. Yeah, is there dev AI NeurIPS? Actually, not. I don't think there is. That would be interesting to have something on that. Maybe not with like the luminaries of finding people, but yeah. I don't know. Well, yeah, they may have something like they may have some papers too at NeurIPS. I don't know what the tracks look like or the accepted papers, but yeah, thanks for the super interesting papers. Yeah. All right. Talk to everyone next week.
Thanks. Take care.
Thanks. Take care.